All right, so we've already learned about different exponents and what they do. We've had positive exponents, we've had negative exponents, we've had the exponent of 0. Now what we're going to do is we're going to see how we use this more in everyday life. Like, where do we see this? So you'll notice we're moving to 2 new standards. We're on standard 8B, which is graph exponential equations. And then 8C, we're going to solve real-world exponential problems. Right? So that'll be your next test. All right? Question. Right? The state of Minnesota says that we need to study exponents. Why? Who cares? They say we need it. Well, where do we see exponents, and why would they be important to us? What do you think? Yes?
In the business world, with large amounts of numbers.
Absolutely. Yeah, we see this in the business world. When we see very large sums of money, the federal debt, right? Where else would we see exponents? We see it in science a lot, don't we? We see it in chemistry, we see it in biology. Another place we see it is space. Like if I'm going from the Earth out to Jupiter, right? Sometimes they write that in scientific notation or using exponents. What else? I know we see it in math, kind of a lame one, right? Of course we see it in math. Well, where else do we see this stuff? In everyday life, where would you look at something and go, oh, cool, I'm glad I know how to do my exponents. Yes? Yeah, if you go shopping, right? Ooh, ing. Shopping? Yep.
Populations.
Populations, absolutely. Medicine. Okay, yes. Yes, road trips. So you're going to notice that we see it a lot, and that's why they have it as a Minnesota State Standard, is so that you don't feel ignorant. You're not like, I don't know where I see that, like, where you see this big, huge number and you have no clue what it means. Okay? Questions on this? All right, let's move on. Notice it asks you to take out a sheet of paper. Right? So you're going to take out a sheet of paper, and I don't care what size. It could be anything. Take out a sheet of paper. You'll be doing an activity with it. Right now, if I just take a look at my sheet of paper the way it is, and I don't put any folds in it, how many rectangles do I have?
One.
I have one, and I'm not going to look at a pattern, and I'm not going to look at any other part. So I'm going to just put kind of a line through that. Right now I'm going to take my rectangle, and I'm going to fold it in half. And it doesn't matter if you fold it in half like a hot dog or a taco. Fold it in half. You're going to need to make a nice, strong crease on that. Open it up. And how many rectangles do you see?
Those.
I see 2 rectangles, which is 2, and I write it as 2 to the first. Okay? So you're going to notice that I got 1 fold, so it's 2 to the 1. Right now, let's keep going. I'm going to take this again, I'm going to fold it like I did, and then I'm going to fold it again. So that I have 2 folds. Crease it really hard. Open it up. How many rectangles do I have?
4.
I have 4 rectangles, which is 2 times 2, right? Or 2 to the second power, because there's 2 folds, right? All right, let's keep going. 3 folds. So I'm going to go back the way I had it. Okay. And I'm going to take my paper and I'm going to fold it again. And I'm going to crease it really hard. And you know, this is really stupid, Mrs. Medvick. You know what? You're going to remember this next year. When you take geometry and the following year, you're going to go, oh, I remember when I folded that piece of paper in your classroom. Oh my gosh, this is crazy. I totally remember this. Okay, how many rectangles do you have?
8.
You have 8, which is 2 times 2 times 2, or 2 to the 3rd power, because there's 3 folds. All right? Take your paper again. Fold it again. Make a nice strong crease. Open it up. How many rectangles? I have 16, which is 2 times 2 times 2 times 2, or 2 to the 4th power. All right, fold it again, one more time. This is hard. Open it up. How many rectangles do you have? You have 32, which is 2 times 2 times 2 times 2 times 2, or 2 to the 5th, right? Well, let's say I could take this and I could fold it 10 times. Physically, can I? No. I can't physically do it. I believe it's like 7 or 8 times you can only fold a piece of paper. So let's say I could, and let's say I wanted 10. Okay? I would write this as 2 to the what? 2 to the 10th. Take your calculators, go 2 to the 10th, what do you get? What is it? 1,024. So I have 1,024 rectangles. That's why we study exponents. We don't have to sit there and go 2 times 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 2, right? That's why we study them. They help us with really large numbers. All right. Let's take a look at another example. This is the rabbit population. Now, it can be the rabbit population. It could be a cat population. It could be a dog population. It could be any animal. Because what happens with animals? They have lots of population issues, don't they? Yeah, they do. And so we're going to take a look at the real life problem with rabbits. So let's suppose we start with 20 rabbits and they're on an island. Okay, and none of them die. They're all healthy animals. Okay, and I know that it triples every what? Half year. So it triples every half year. I want to know how many rabbits there are going to be after 2 years. Okay, so I'm going to go ahead and I'm going to make a table. Now you're going to do this in your homework, so you want to pay attention. Okay, I've got the time being initial. What does that mean? Like right at the start, right? So I'm starting on this island, okay? And I've got 20 rabbits, and I'm just going to leave it like this. And then a half a year went by, which is 6 months, right? And what happened to those animals? They did what? They tripled, right? So that's 20 times 3 to the 1, or 20 times 3, which is 60. Okay? Let's go on. How much time took place?
1 year.
1 year. Okay? So that's 60 times what?
33.
Which is 180 rabbits. Holy buckets, right? So I write that as 20 times 3 to the second power, because that's the second, like round, shall we say? Because we did a half a year, that was the first round. 1 year is the second round of 6 months. All right, let's keep going. Now I'm going to do what? 1.5 years. So 180 times what?
3.
Gives me 540. Wow. Or 20 times 3 to the third. Okay. Let's keep going. How much time went by? 2 years. What am I going to do? How many rabbits do I have? 1,620 little tiny cute bunny rabbits, right? Yeah. Or 20 times 3 to the fourth. Now, let's say I want to know what happens after 3 years. But I don't want to do all the work like the middle. What would I do with exponents? Yeah.
Just 20 times 3 to the 6.
Where did you get 6 from?
Because it's 2.5 years later.
That's correct.
So 4 plus 2 is 6.
That's correct. 2.5 years later, so we've got 4 plus 2 is 6. That's right. Okay. Go ahead and do that. How many bunnies do I got? 14,580. Wow, that's a lot of little bunny rabbits, right? Now you can see why it becomes a problem, right? Even cats out on the farm can be a problem. That's why a lot of times they spay and neuter them, because it can become a huge population issue. And then disease can set in and that type of thing. Okay? That's exponential growth. All right. Now, this is going to be like your homework, right? And we did a lot of this like we did with linear. The first thing we're going to do is we're going to make an H table. A lot of kids like this, and the reason why they do is this something new? No, we've done H tables so much, it's not even funny. And when I say domain, what's another word for domain? Input. Okay, what is the opposite? Output or range. Yeah. So a lot of what we did with linear is going to help us with exponential. All right. So you'll notice they told us to put numbers in for the domain. So I'm going to put in 0. Y equals 3 to the 0. What does that give me? 1. Thank you. So some of the things that we've worked on is going to help us today. I'm going to put in a 1, so y equals 3 to the 1, which is 3. And then I'm going to put in a 2, y equals 3 to the second is 9. And so then I'm going to list my range. And I've got 1, 3, and 9. Look familiar? Yeah, we did this with linear. But now we're doing it with exponential. And we'll also be doing this with quadratics later, or parabolas later. Okay? So one of the reasons why I did what I did when we did linear, we did it over and over and over again, is we would revisit again this type of problem. Questions? All right, let's move on. Next type of problem. Notice it asks me to graph the function. All right, so I'm going to put in x, y equals 2 times 3 to the x and y. Now, what do I plug in for my domain? Whatever I want. And what did we say when we did linear was good? Negative 1, 0, and 1, right? Because we like that negative number in there. So you're going to do that again. I'm going to put in negative 1. Now, there's more work shown on this. And make sure that you show your work. Y equals 2 times 3 to the negative 1. Y equals, what do I do first? Exponent. Yep. So it's going to be 2 times what?
It doesn't go downstairs?
It does go downstairs. So
1 over 3.
1 over 3. Yep. Don't write it as a decimal. You don't need it. Y equals then, it's 2/3. And leave it as a fraction. Don't put it as 0.6 repeating. It's easier to graph with this. Okay, now I'm going to put in a 0. What do I do first? Exponent y equals 2 times. So I get the last one. Have we seen this before? Yeah, we're just starting to put all our stuff together. It's like, well, why did we do that before? Well, the reason why we did is now I'm starting to pull. I'm starting to pull from your skills. And when you do your homework and you follow through, this isn't bad. Make sure you fill in all the steps and show all your work. Because a lot of you will be handing in homework this chapter, and if you don't have your work, I don't accept it. You know that. All right, so now graphing it. Now some students are like, I don't get this graphing stuff. This is just not very fun. Okay, so I'm going to grab the green because I'm going to do the green dot. I've got -1 and 2/3. Now where is the 2/3 located? Okay, if it's slope, it's up 2/3, but I'm not doing slope because this isn't linear. Between 0 and 1. Now, is it going to be dead on perfect? It's not, and that's okay, right? So I'm going to go -1 and 2/3, and it's going to be about right there. Then I'm going to grab my blue dot, which is 0, 2. And then I'm going to grab my red dot. And I get 1, 6. Now, be careful when you connect the dots. Why would I connect these dots? Because why? It's part of the same function. I chose the dots. Just like linear, right? Just like linear. That's why we did what we did, and I collected your homework and made because we're doing it again. Be careful when you connect these, though. They are not linear. They are not aligned. And when you connect them, you're going to start as close to the x-axis as possible without going over it. So it's going to start like this, and then it's going to take off. Boop. Boop. It will never cross the x-axis, ever. And so if you touch that x-axis, I will count it wrong. Okay, and it's not because I mean, it's because it's wrong. Let's talk about that, right? As I do more negative numbers, okay, so in my x column, if I chose -2, would I get a negative y? No, I wouldn't. How about if I put in -3 for x? Would I get a negative y? Is there a number that I can choose for my input that will ever make this function negative? No. That's why I don't cross the x-axis. Okay? So you want to be really careful. You want to put arrows on either end, and you'll notice it's kind of a, it's not a J because it doesn't scoop up. It's kind of an L shape. So this is some graphs that you're going to see. So let's say you have the x and y axis like this. You're going to see some graphs like today that are going to go like this. It doesn't scoop up quite that much. You're going to see a graph that looks like this. Again, does not cross the x-axis. You're going to see a graph, and this freaks kids out. And you're going to go, well, you said it never crossed the x-axis. Like, what's going on? What's going on is this. If R2 See, it says 2 times 3 to the x. If that 2 were a negative number, then all of my y values would be negative. Okay? So when it happens, the green graph is what it looks like. It won't cross the x-axis, meaning it will never be positive y. It won't. So that's why it doesn't cross the x-axis. And then we have another case where something like this. So they get closer and closer and closer to the x-axis, but never cross it. It will never be a line, a straight line, ever. And so if you graph these like a line, I'll call it wrong, because it's not linear, it's exponential. Because remember, for it to be linear, it needs to be y equals mx plus b. Okay, that is not what this is. It's exponential. It's like y equals a to the x. See the difference? All right, so today what we're going to do is we're going to do worksheets. These will be in Schoology, all right? And you can also find the homework in a Schoology.